Hello, good morning, everyone. Welcome to the press conference about the first at-home blood test to detect and measure over 40 PFAS compounds. We are so excited that you're here, and we're excited to share this innovation with you. I am VP and General Manager of empowerDX. My name is Delia Vallejo, and empowerDX is a leading online health resource for a variety of easy at-home self-collected lab tests. This product is a new product for us, and it is the first in market and very innovative. And we have several people here that will answer several questions that you might have and tell you more about it. A little bit more about empowerDX. We offer over 20 tests directly to consumers, and we've partnered with several US labs that meet the highest standards of quality and accuracy to deliver results directly to the consumer via a secure website. This convenience for at-home health testing is to remove barriers to access and to offer answers to people that they may not have in the regular course of healthcare. Now, this test in particular is first of its kind, and it tests for over 40 compounds of these forever chemicals. The test will retail for $3.99, but we are excited to offer it for an introductory price of $2.99, which is the lowest price in the market, and less than $10 per compound, and again, the lowest price in the market. This is a differentiated test because it is measuring 47 compounds. Now, without further ado, I would like to introduce Dr. Travis Wilkes, who is Medical Director of empowerDX and a family practice doctor, and he will explain the medical consumer case for this product. Additionally, Dr. Wilkes will show a video demo of this easy self-collection method for this PFAS test.
Thanks, Delia. So I think the video is going to start playing in a second, which is very interesting. So let's talk a little bit about PFAS. So I am very excited to be part of this team to launch the first at-home PFAS test. So PFAS, a lot of people may know something about it because they may have seen something that said PFOA free or something like that, but I think that it's sort of a mystery to most people that what it is. So we've gotten comfortable with certain types of environmental contaminants, both natural and unnatural, things like radon and asbestos and mold. And so I think we all think about our exposures to these kind of things. But PFAS, these forever chemicals, I think people just don't really think about how much they've been exposed to them, how that can have an impact on their health, and how do they know how much they've been exposed? Because it really is very hard to sort of reflect back and understand how much exposure you can have. So one thing to think about is why do you want to know? So these forever chemicals seem to be able to linger in the bloodstream for very long periods of time throughout your life, and can cause it can basically cause things to happen that lead to other health issues. So what kind of things? So things like cholesterol can be affected. It can affect liver function, which can be detected on liver function enzymes in blood work. There's been associations between higher levels of PFAS and increased kidney cancer and testicular cancer. There's also been issues around pregnancy and around early child development in general, but largely in pregnancy, there's associations with high blood pressure that can develop in pregnancy, which is a condition called preeclampsia. So, all of these things taken together, you really, I think it's one of those things where this is all around us. It's everyone is exposed to it. And I don't think that it's something that we should sort of say, well, we should be really afraid of this, but I think it says, well, let's be aware of it and let's take reasonable measures to avoid it. And then if we detect that we have had a large amount of exposure from our environment, then let's know that, and then let's use that as a tool to figure out, okay, what should I be doing for screening? How should I be looking at my health, and what can I be doing to be proactive for my health? I think that this may come to the forefront a little bit now with our COVID pandemic, because we definitely think that PFAS can have an effect on immune function. And so if PFAS is having an effect on immune function, then it can have an effect on how we respond to the COVID-19 virus as well as vaccines. And so there's been several studies that have highlighted the reduced efficacy of different vaccines with elevated levels of PFAS. And so keeping that in mind, I think, is really, really important. And I think that there's going to be a lot more to come on that. I mean, we don't have very good definitive answers right now, but we are, the scientific community is approaching that head on and studying it. And I think that in the years to come, we'll know a lot more. And so what that means is the more you can know about your exposure level now, then the more you can sort of prepare as that information comes out and be sort of a better, a more proactive, savvy patient when you talk to your doctor. So if you go to your doctor and say, okay, these are my issues. I worked in a coal mine for 20 years. What's my risk of that? They're probably going to be pretty comfortable in saying, okay, we need to look at these things. You have higher risk. If you go and say, I've got higher levels of PFAS, there may be less of a comfort. And I think that's going to change in coming years. I think that primary care doctors are going to become more aware of PFAS and then figure out ways that they can sort of screen things differently and approach things differently for people who have elevated levels of PFAS. I think that there's some very simple, straightforward things that we can do from a health standpoint that I think the CDC has done a pretty good job of getting the conversation started and sort of creating a foundation that we can build on. So probably other questions that I'm just going to read people's minds and wonder, what are they wondering about? So how do you get PFAS in your body? So you probably get it in your body through ingestion of eating or drinking. So it could be on cookware. It can be in the lining of food containers. So you could get it through food. You can get it through water, contaminated water supplies. Fish in certain areas may consume a lot of PFAS, and then that, if you eat those fish, then you ingest that. Inhalation is another probably very common method from different kinds of materials, waterproof materials and stain-resistant materials and things along those lines. And then you've got a whole world of occupational exposures. But what I think about more, the occupational exposures, it's easier to kind of read in from a doctor's standpoint and understand someone's risk based on occupational exposure. It's much more difficult to try to find environmental contaminants that can affect someone's health when they don't have that exposure. And so that's what I'm really excited about this test. It offers a way to look at those people who you wouldn't necessarily say this person has a high risk of exposure to PFAS, but they do because somewhere in their life they had a high exposure. So that is, in a nutshell, how I'm kind of viewing this. And I'm sure there's going to be several questions, which I am happy to get to.
Thank you, Dr. Wilkes, for that overview, and thank you for being such a champion of this test as our medical director. Next, I would like to introduce two worldwide experts of PFAS. We are so fortunate to partner with our reference lab, and I'm happy to introduce to you Taryn McKnight, who is a PFAS practice leader, and Andrew Patterson, who is PFAS technical director for our reference lab. First, I would like to begin with Taryn with the question, and if you could share the background on these chemicals, how they were made, where do they come from, and why are they called forever chemicals, which is certainly a scary term.
Yeah. So they're man-made. These are not naturally occurring. So there's no normal amount that should be in our bodies. They're made through a variety of processes that involve what's called fluorination. And what's really unique about that process is it's bonding carbon to fluorine And that's one of the strongest bonds in nature. And so there's no known natural degradation process for breaking down that bond. And that's how we end up with forever chemicals. So there's no natural way for them to break down in the environment or in our bodies. How long they will last is really unknown right now. It's thought that they might last for hundreds of years. It could be even longer than that. We just haven't reached that point yet to know conclusively. They're used so widely in industrial products and processes and consumer products that they are essentially ubiquitous worldwide. So they are found everywhere on our planet, in humans and wildlife. They're in the Arctic and Mount Everest. They're found everywhere. And this includes our drinking water, groundwater, soil, the air we breathe. And as Dr. Wilkes mentioned, all of those consumer products that we're exposed to.
Thank you, Taryn, for painting that picture and explaining it so well. You mentioned that they are in our environment, but also in the products that we use. Can you give us an example of what kinds of products these are found in?
So there's a lot of research being done right now to better illuminate exactly which products these are found in, but I think it's helpful to think about the properties that these chemicals impart. So that includes water repellent, stain repellent, non-stick, friction reducing. So you start to think about any of the products in your life that have those qualities, you can start to get a better idea of what products they might be in. And that's everything from flooring, furniture, clothing, food packaging materials, cosmetics, cleaning products. And I'd say every couple of months, there's usually a group of researchers that publishes something on a specific set of consumer products that we can kind of reference and start to get a feel for which PFAS chemicals are in them and at what levels.
Right, Tim. Remember there was the publication just came out about anti-fog spray for lenses and for screens.
That's right. That came out the day after I added the fog spray to all of my glasses.
Right. I mean, with everyone wearing masks, that fog spray, I'm sure, has just increased in use. Wow. Now I have a question for Andrew. Can you tell us a little bit more about this test and just explain, what leads to the price point, but also just, what makes it special and what it actually does?
Yeah, you bet. Really, the ability to test for PFAS in human serum has been around for a long time. NHANES has been collecting data since 2011. I've myself have been testing for PFAS in blood since about 2008. So it has been around a while, and the sophistication to do that is even a little more so than your average aqueous sample, because the fact that you have a smaller sample size and the fact that you're really concerned with any sort of background that might compromise that small sample size. So the instrumentation to do either an aqueous sample or a blood sample is already sophisticated. We've actually invested in the latest generation of, they're called triple quad mass specs, to be able to do this with certainty. Those are quite expensive. They are over $500,000 a piece. And what we've really built is a lab within a lab. Eurofins is the support lab for empowerDX. And this whole pathway that these blood samples take is unique. It's controlled, and it is for all intents and purposes a lab within a lab to be able to keep our background low, our PFAS background low, and to be able to deliver the most sensitive results. So, I know $399 sounds like an expensive price point, but it's actually, people on this very call were advocates for getting that price as low as we could get it. Honestly, a typical PFAS aqueous sample starts out at pricing about, not terribly cheaper for the analyte list that we're getting here, this 47 analytes. So it really is, I know it seems steep, but it really is a pretty amazing price point for the quality of of data that you get, and the certainty that, you know, the lab that's performing this analysis knows what they're doing with PFAS. We perform thousands upon thousands of PFAS samples a month, and any matrices you can consider. And so this is a natural fit for us, to be able to offer this. This is not like a simple water chemistry test or a fluoride test or something else that would be very general chemistry based. This is very specialized, and we know it. And, you know, and we're not making any outlandish claims about the millions of things this test could do, but what it does do is determine the concentration of PFAS in human blood with certainty.
Mm-hmm. Thank you for that, Andrew. And I see some questions coming in through the chat now, and I just want to remind everyone to feel free to put your questions in as the presentation goes, so that so we have them in queue for the end of the press conference. I have another question for Andrew.
Mm-hmm.
So when someone has our results, what do they do with them, and how do they understand the report that's delivered? And, you know, the kit comes to your home in this package, and you order it very simply from the website. It arrives in your home. You self-collect via the process in the video that Dr. Wilkes showed. You send it back to the lab, and the results come back to you on the website in a very secure way. But once you get those results, what do you do with them, Andrew? And what do the significance of the exposure levels mean?
That's a good question. And I think we do have a couple of slides that would better illustrate this process or the reporting for what you get. And again, you know, these results are securely uploaded from one lab to the Empower lab, and that's it. They're not handled by anybody else. So what do you do with your results? If somebody's seeking out a PFAS test, PFAS aren't new to them. So I think the knowledge here is power, where you can say, where do I fit in? I think it's pretty well established that somebody is going to have some positive results for their PFAS test. You know, that's not surprising, but really it's more a matter of how do I fit in to the national averages. So one thing, you know, we do supply right now is this is an illustration of the report that you would get. We do supply a whole blood concentration, and that's the actual concentration that we measured with our test. And then to be able to look at sort of apples to apples with the NHANES CDC data, we're providing, where available, serum equivalent. So I guess in this example, the person has a PFOA level of 1.6 nanograms per mil. We then use the conversion factors, the published conversion factors, to arrive at a serum equivalent. And you could take this serum equivalent, and then you could then compare it to the chart you see down below here. So this person would be on the higher side for PFOA, but you know, that's again, there are different metrics that you can use in the NHANES to tease it out by age and sex and other metrics. But really, this would be a snapshot. Someone could take a look at this and a look at the NHANES charts and say, okay, you know, here's about where I fit in. You know, and we do have people from all walks of life. We have people that want to just say, you know, I'll sleep better at night knowing I'm about average, like everybody else. We have other people that are a little more health conscious, and you know, and they may want to not be average. They may want to say, I've taken a lot of time to avoid PFAS. You know, I want my results to be less. And then we have other people that might have had some occupational exposures or live in impacted areas, and the results might be quite a bit higher. But it's really ironic to me that, you know, until this test, getting the results from your own body was something that was quite difficult to do. You needed a phlebotomist, you needed a blood draw. The test was quite a bit more expensive, and you might be waiting well over a month just to get these results back. So I do think the knowledge is power in this case, and we're supplying a means to get to it.
Andrew, can I add something there for you?
Yeah, you bet.
So I think one of the big things that you kind of alluded to that I think is really important is that not only did you need a phlebotomist and that stuff to actually get the blood drawn, but if you went to most doctors in the United States or in the world really and said, I'd like to get a PFAS test, they don't have access to a lab that can do that. So they don't have, they've got no sort of account or relationship where they can say, okay, let me draw your blood and send it to a lab and we'll tell you your level. And so that not only are you do you have limitations because of the actual need for phlebotomy and all, but also most doctors didn't even have the capability. I mean, I did not have the capability to go and order this test for a patient before the availability of this at-home collection kit. And, you know, I think about that constantly because information is not, there's so many barriers to information that go beyond just collection and things like that. It really, I think, underscores how important this test is, and the fact that it is direct to consumer, available for order, self-collection. I mean, it just democratizes access so much, and I'm just really thrilled about all this.
Yeah, I agree with you, Dr. Wilkes, and having personally tried to coordinate mobile phlebotomy blood draws for PFAS tests in the past, I can tell you that there is a reluctance to draw someone's blood unless there is an established request from a doctor. So I think you can attest that this really is between yourself and your results, and possibly another medical professional like Dr. Wilkes at some point. But it's I don't want to say it because it's kind of a pun, but it's a little empowering.
That was the point, Andrew. Thank you.
Okay, you're welcome.
I do have a question for Taryn or Andrew, or if you can both weigh in on this. How is the Environmental Protection Agency addressing PFAS?
Boy, it's a long PowerPoint. We'll put it that way.
Let's just say there's been a renewed sense of urgency under the new administration. So last year brought a flurry of activity. They have what they call a PFAS roadmap with a variety of initiatives that cross all the different divisions of the EPA. So they're looking at addressing it in drinking water and air and consumer products and excuse me. So they have this comprehensive plan, and we've actually started to see actions be taken from that plan. So that plan just came out in October, and they've already started kind of checking off the list. So like I said, a renewed sense of urgency, pretty comprehensive plan. I think some of the things that are most important to maybe the people who are listening to this call is the actions around drinking water, because when you think about environmental exposure, that's where you're consuming water every day, and every person has to consume water. So it's really important to get those regulations in place, and that process is underway, but it's not a quick process. So we're still a couple of years out from having those standards in place.
Thank you, Taryn. Andrew, anything that you would add to that?
Oh, no, just, you know, I think it's too bad, but we're in the boat that we are in now, where, you know, PFAS are ubiquitous in the environment, and we're only just now learning about some of the toxicological effects, more and more so as we go on. So, you know, what this test does is it really, it says, okay, even though we may not understand all the tox behind all these myriad of different PFAS, we now have the ability to capture, you know, 47 of them, and that list is probably going to be growing as we develop sophistication with this test, and requests from research groups to add on certain PFAS. It's pretty amazing, and we're here to make it grow, and we're here to get input from the public. Our goal at Eurofins is testing for life, and this really aligns with that mission statement.
Thanks, Andrew. All right, so I would like to now open it up to our participants for questions. So I'm going to take a look in the chat to see what questions we have. And then I will call on our participants depending on the question. Let's see. Here's a question that maybe Taryn, you can take. how can we find out if we live near PFAS sources?
Yeah, that's a great question. I can tell you two of the most obvious sources right now that we are knowledgeable about is military bases and airports. So if you know you live in close proximity to one of those, it's definitely worth investigating immediately. But beyond that, there are some resources out there. There is the Environmental Working Group has been very active in trying to bring awareness to this issue. And so they've created a map of the United States on their website where they track and post information about detections of PFAS in the drinking water of communities near various types of sites like military bases. So you could start there, look at their map, and then depending on what state you live in, there are states that post this information. So as they conduct their own surveys of drinking water, wastewater, groundwater, a variety of different things, they'll make that information publicly available. So, and if you need help with any of that information, we're always happy to assist with that as well.
Thank you, Taryn. I have a question for Andrew.
Mhm.
What are the detection limits like comparable to aqueous samples?
So aqueous samples, and we have had this question before. So aqueous samples to meet certain regulations have to be in the low part per trillion range to be relevant. Our standard detection limit for a PFAS aqueous sample right now is 2 ppt, or that's 2 nanograms per liter. Unfortunately, humans to be in the biologically relevant zone of concentration for a test need to be between 100 to 500 ppt. And that's right where we're at. Most people for PFAS and PFOA in particular are quite a bit higher than that. But as we grow our list, we want to make sure we're not missing anything. And so we try to be at 100 ppt across the board where we can. There are a couple that are a little bit higher, but really it's in a zone that it needs to be in. And if there was, if there is a need with, as we discover more exotic PFAS, to go lower, we would have that ability. But really we're in a great spot right now with our test and our instrumentation, and so we're happy with where we're at.
Thank you, Andrew. This question is probably best for Dr. Wilkes. Can a regular doctor interpret this, and what can you do to change your levels?
So I think if you asked most doctors, they would be uncomfortable saying, okay, you've got elevated PFAS levels, I know exactly what to do. But I think because there's very reputable organizations like the CDC that have put out information about this, they can, with a little bit of research and maybe a little bit of more information, they can make sense and sort of develop a plan. In terms of getting rid of PFAS, I mean, the main way that you're going to be able to get rid of PFAS, well, two ways. One is going to be stop adding to it. So stop collecting PFAS in your body, which is taking strategies to kind of mitigate that. The second, you can get rid of PFAS in the blood by donating blood, which I'm generally a huge blood donation advocate. I think that there's a number of benefits of blood donation that go way beyond just helping other people. Blood donation gets rid of iron, which iron overload can be a very big problem for people. It can also get rid of PFAS, which is also very useful. So I think that probably the easiest strategy to get rid of PFAS is avoid it and then donate blood. And the questions come up before, well, if I'm high in PFAS and then I'm donating blood, am I potentially causing harm or something like that? And I think that the way that blood donation works, people are getting a small amount of blood during very high risk times of their life, and it's life saving. And so, I think that the long-term consequences of PFAS and sort of spreading PFAS out in a population is less concerning in an acute moment of a car accident or something like that. I mean, I personally would be more than happy to get high levels of PFAS if I was in a car accident and needed blood, or the other option was death. So donate blood, and then take a number of strategies for sort of risk mitigation, screening for health issues when you know this information. So I think about this like, if we know that someone has asbestos exposure, we often do imaging of their chest, chest x-rays, CT scans. If we know someone was a smoker or is a smoker, then we calculate out what we think is their exposure level based on pack years. So how many packs did they smoke per day over how many years, and that gives us an exposure. And then we often monitor people with CT scans of their lung to understand that. So with PFAS, we're not as well developed in terms of an organized guideline-based approach, but we know that, for instance, that PFAS seems to increase risk of testicular cancer. And so the high risk age range for testicular cancer is young men. It's not, it's sort of this men in their college to early adult years. And maybe you find out that you have high PFAS, you test your 22-year-old son and he's got high levels of PFAS. Well, then, there's an increased urgency then to make sure that he's doing a monthly testicular exam. And I think that's like a good example, because it's not a fear-mongering thing. It's not saying just be super afraid and worry. It's, okay, how do we use this information to be very proactive and take steps that are useful, but don't lead to fear. And so if you can get a 22-year-old to do a monthly testicular exam, then he may develop testicular cancer, and the detection would be very early. And early detection with cancer is everything. If you look at survival rates, it's really everything. We see similar things with like increased levels of cholesterol. So, you may look at cholesterol and liver function tests differently if you have this understanding that the patient in front of you has high levels of PFAS. So I think that with a little bit of education, every doctor should be able to sort of say, okay, this is a reasonable way that we should approach your risk differently at an individual level. And I think that's really what the key is to try to get individual care. You want care that's based on your genetics, your lifestyle, your environmental exposure, not necessarily someone else's. And so when you get recommendations, you want them to be tailored to you. And this is just one piece that allows that tailoring process to happen.
Thank you, Dr. Wilkes. This question is related, but different. And I'll just pose it to the group. How often do you recommend getting tested for PFAS? The question goes on, is it something that you should do frequently, or is it just something that you do when there's a life transition, different geography, different job, for example, that may expose you to different environmental PFAS?
I'll jump in on this one, and I'm sure Dr. Wilkes, you will have something to say too, but more on the side for PPE. You hear a lot in the news today about masks, but depending on your occupation, you may want to get a baseline test initially if you're starting a new position, which may have higher occupational exposures to PFAS, and that really gives you an idea. Okay, where am I starting? And then as you progress through that job, you yourself or your employer may want to say, are your PPE protecting you? Are they doing the job? And so you, outside of any other additional exposures, your levels shouldn't be climbing. They should be staying the same if no other changes in your life have occurred. So really there's no set answer. The first test will give you an idea. What have I accumulated to date? Where do I stand? Tests after that will say, well, is this about the same? A little bit higher, a little bit lower. I'm just a normal progression, or are my levels climbing because of a change in my life?
Thank you, Andrew. Dr. Wilkes, anything to add on that?
Yeah, I mean, I sort of think about it as, everybody should have baseline information about themselves, and then you think about life event triggers. And so if you take a new job, if you move somewhere, if you end up living in a different country for 5 years and you come back. I mean, these sort of life events should trigger things. But otherwise, I think that, some sort of a reasonable degree of checking and rechecking is probably helpful. I mean, I don't think that we have good guidance on it, but I mean, for me personally, I would think probably like, I'd want to know what 5 years of my life did. And then you can kind of reflect back on those 5 years and say, okay, what happened? And then you may take some sort of other strategy based on that. So it's about sort of developing a strategy. Now, some people may want to go tighter than 5 years. Some people may want to go longer. But that's sort of my personal view of it.
Thank you, Dr. Wilkes.
And I should point out that we have had corporate inquiries for people in the wastewater treatment industry, where people are going to be getting a baseline test, and then they're going to be testing biannually to ensure that everyone's the expectations are met. So this isn't science fiction. This is reality.
Mm-hmm. Thanks, Andrew. This question is probably best for Taryn. Is it known which states track PFAS contamination? And then a second part, maybe for Dr. Wilkes, is PFAS removed during dialysis?
Yeah, so I can share a number of states that we know have been investigating around the state to uncover potential sources of contamination. That includes California, Colorado, Michigan, Minnesota, and then most of the states in the New England area: Maine, Vermont, New Hampshire, Massachusetts, Connecticut, New York, and New Jersey. I would say most of the Midwest, Northeast has been pretty progressive about PFAS site investigations. It's really in the middle part of America and the South where not much progress has been made.
Thanks, Taryn. That second part of the question was, is PFAS removed during dialysis?
I'm not quite sure if it's removed during dialysis or not. I mean, I haven't seen any studies. I'm not sure if any exist on it. It's sort of a difficult population to study. Dialysis patients have chronic kidney disease and have a lot of other sort of issues. And I don't think that it would be possible to pick what I think is really the question gets into is, can you get rid of PFAS by dialysis? And we would never do dialysis on someone who did not have end-stage renal disease because of some of the complications within it. But the bottom line is I'm not sure.
Thanks, Dr. Wilkes. Scrolling through the questions, I think I covered all of them. There was a question that was answered within the chat around can these tests be run on children? And we're happy to offer it to children ages 6 and up. And there is a smaller lancet for the finger prick for children, and it's clearly outlined in the instructions that are included in the kit.
Yeah, and I actually I like that question because children were one of the drivers for developing this test. The previous test did require a blood draw, sometimes 2 or 3 tubes of blood, which was pretty taxing on smaller individuals and especially on children. So getting this to a finger prick or a heel prick, although it's not the most relaxing thing to administer to your child, it sure beats going in to have a blood draw.
Mm-hmm. Absolutely. And I wonder if we can show the video again, just illustrating how easy it is to do this at home, right as we wrap up. We have about 1 more minute for questions. I'll just say that, and I think we answered all of them. Actually, I did miss one here. Will the test results tell you if your levels are in the danger zone for a specific PFAS? And Andrew, I'll ask you to take that one.
Yeah, so there is no established toxicological level for PFAS. As Dr. Wilkes would say, the expected level for PFAS in the human body is 0. So anything above that is not expected, but it unfortunately is typical, especially in the United States. So there are no established danger zones for PFAS yet.
Thank you,
So
Andrew.
I like that question, because that's the question I think about all the time, which is like, how many cigarettes do you have to smoke to get
Mhm.
lung cancer or emphysema? Or how many sodas do you need to drink to develop diabetes? And you know that it's I think it's really, really individualized, and I think that that's why it's really important to work with a doctor with your results, because it's important to remember that PFAS exposure is an environmental indicator. So this is giving you information about how much PFAS you are exposed to in your environment. It's not a direct health determinant. So it is not telling you the same thing as like a liver function test will tell you about what your body is actually producing. And so it needs to be sort of interpreted in that context of you as a unique individual, the PFAS level as an environmental exposure. And then I think only a doctor is going to be able to kind of pull those together and try to help develop a plan that's personalized to you based on that. Because also things come into play, like you may have genetic risk that come into play. You may have a family history of thyroid issues, and is your thyroid level being checked often enough? Maybe I check. I usually recommend people get their thyroid levels checked annually to keep track of it. But if you have an elevated level of PFAS, then it would be really important that you get your thyroid level checked annually to monitor that. So it's all about that bringing together you as a unique person and your environment and all the exposures it brings, because you could have high PFAS exposure, but you could also be a person who has high asbestos exposure and high PFAS exposure. And then, in my mind, if that patient came to me, I would be like, okay, what am I going to do to try to make sure that whatever happens, we catch things early, and what is the most preventative course we can take? And so, that is, I think, on the physician side of things, of like piecing this together, but trying to look at like danger levels and things like that, I think are not the right way. It's more to look at exposure, how much, and then you as an individual.
Thank you, Dr. Wilkes. So we don't want to keep people over time here, and we will wrap up. But I do want to leave everyone with a few reminders. So on the screen, you have our press contacts, and I wanted to just remind everyone the process for ordering the kit. So it's available on the website. The introductory price is $299, and we're excited to offer it for that introductory price for a limited time. And you order the kit, it arrives in your home, you register and activate, you self-collect via the easy process demoed in the video. Send it back to the lab results it, and you receive a secure lab report when you log into the website. In addition to that, you get a test guide that gives you information for how to interpret, and you see a screenshot of that on the screen here, and what you might do with your results. So we have really great content for you to learn more about PFAS and what it means and what it does, and a lot more content about the test on the website. So feel free to explore it there. This press conference is being taped, and you can view it again in our newsroom on the website. And please contact Amanda or Becky for the press kit. We put together a very detailed press kit, and to book any interviews. We are so excited about bringing this test to market, and we really think that it's going to make a difference. Yes, just thank you so much for participating, for your great, insightful questions. And also thank you to our participants, Taryn, Andrew, Dr. Wilkes. You are just such experts in this area, and then I learn every time I hear from you. So thank you, everyone.
Thank you.